Hi guys, okay, so today we're going to talk about working with equations, and we're going to start by defining what an equation is. So an equation really is a mathematical sentence that states that two items on opposite sides of an equal sign are equivalent or equal to each other. What does that basically mean? It means that two things are equal to each other and they're separated by an equal sign. Okay, so for an example, 1 plus 5 equals 3 plus 3. Okay, that's an equation. It says that things on this side are equal to things on this side. Okay, so the left expression is equal to the right expression. That's what an equation says. In this case, it says the sum of 1 and 5 equals the sum of 3 and 3. And why is that true? And remember, equations don't have to be true. They can be false. But for the most part, we're going to try and find what makes an equation true. Okay, it's true because both equations, the left and the right side, are equivalent sums. Okay, the sum of each is 6. 1 plus 5 equals 6, and 3 plus 3 equals 6. So in each case, it's absolutely true that 1 plus 5 does equal 3 plus 3 because they're both equal to 6. So let's look at an example. Justin and Tyson are beginning an exercise program to train for football season. Justin weighs 150 pounds and hopes to gain 2 pounds per week. So the first thing we could do is write an expression for Justin. Because remember, we're going to need the expressions in order to create our equation. So let's say we've got 150 pounds and he's going to gain 2 pounds every week. Gain would mean add. Good. So 150 plus 2 pounds every week. So W would probably be good a variable because we're talking about week. So W stands for week. And whenever you write an expression, you should always identify what your variable means. So in this case, the W stands for weeks. So let's do the same thing for Tyson. Now Tyson weighs 195 pounds and hopes to lose 1 pound each week. So he hopes to lose a pound. Well, lose a pound wouldn't be adding, but lose a pound might be, or is, subtracting. So 195 minus W. Once again, where W stands for week. So he's going to lose 1 pound every week. So now let's talk about how we're going to use those two expressions. And we have a task to do. Write an equation that can calculate in how many weeks the boys will weigh the same amount. Same amount means that when are those two boys going to weigh equal amounts? So we're going to talk about an equation. And we have two expressions that we can set equal to each other. So Justin's expression is 150 plus 2W. Tyson's expression is 195 minus W. Two expressions, we want to find out when they are equal, when they have the same amount. Okay. Now we want to find the value of W that makes this equation true. So what can we put in for W that makes the left side equal to the right side that makes this equation a true statement? So in order to solve this equation, we have to isolate the variable. And that basically means to get W by itself. But notice we want this W to have a coefficient of 1, not a coefficient of 2. We want to have one W, not multiple W's. So there's our work, guys. Now let's go through it and see exactly why we're doing what we're doing. So the first thing we want to do is add W to both sides. Why? Because we're taking away W here. And remember, ultimately, we want to get all the W's on one side and all the constants on the opposite side. So all the variables together, all the constants together. So we're adding W to both sides because we want to use the inverse operation. Remember, inverse operation means if we're adding, we want to subtract. Okay, so that's what we're doing there. So we add W to both sides, and what happens? We end up with 150 plus 3W equals 195. Why? Because negative W plus W equals 0. Okay, they eliminate each other. So we're left with 195 on the right side of the equation. On the next side, left side, 2W plus W equals 3W. So we combined like terms here. We're simplifying our expressions on both sides. All right, so what do we do next? Well, we want to get all the constants together. We got all the variables together now, but we want to get those constants together. So since we're adding 152 on this side, let's get the constants over to the other side, get it away from that 3W. We have to subtract 150 from both sides. Okay, opposite operation. Inverse operation of adding is subtracting. So we want to subtract from both sides. All right. Then once again, we simplify. 150 minus 150 leaves us with just 3W on the one side. 195 minus 150 gives us 45 on the other side. Now you can see both sides are simplified. And if we look at it, guys, all the W's are on one side, all the constants are on the other side. But remember, we only want one W, not three W's. So that's why we have to divide both sides by 3. Why? Because that's the coefficient. We want that coefficient to become just 1. So 3 divided by 3 is W. And since we did divide by 3 on this side, you always have to do the same thing to both sides. We do it on the other side. So 45 divided by 3 is 15. And we've got our answer. We simplified both sides. So in 15 weeks, the boys will weigh the same amount. In 15 weeks, they weigh the same amount. So how can we use that to our advantage? Now we know that it's going to take 15 weeks for the boys to weigh the same amount. We could now figure out how much each boy will weigh in 15 weeks. So to answer this question, we can either evaluate each expression separately and then compare the results, or we can evaluate the entire equation at one time and then check for equivalence, which is actually the more preferred way to do it is this way. Hopefully, we'll get there. But for right now, whichever way you want to use, this way takes a little bit longer, but it gives you the same result. So there's our expression, 150 plus 2x, and we're going to evaluate, so we have to substitute that 15 in. So 150 plus 2 times 15 is 30, which is 180. For our second expression, Tyson's expression, 195 minus x, so 195 minus 15 equals 180. So you can see the two expressions do equal the same thing. Or we can evaluate our equation. So 150 plus 2x equals 195 minus x was our equation. Now all we got to do is substitute and evaluate. Wherever we see an x, it's now 15, because that's what we found, 15 weeks. So 150 plus 2 times 15 is 180. 195 minus 15 is also 180. So you can see this is a much easier way to see that the equation is true. 180 equals 180, so we have a true equation here. In either case, you can see the boys will each weigh 180 pounds at 15 weeks. Let's try another one. The Rapid Rental Company charges $40 rental fee, $15 for gas, and 25 cents per mile driven. For the same car, Capital Cars charges $45 rental fee and gas, and 35 cents per mile driven. So these are our tasks. Find the number of miles for which both companies charge the same amount. How much is that charge? And then there's a little story for you here. The Barr family estimates that they will drive about 95 miles during their vacation in Hershey, PA. From which car rental company should they rent from, and why? So you can see we have our information at the top, so we can write out our what? Write out our expressions, because we need to write out expressions before we can write any kind of equation. So task number 1, find the number of miles for which both companies charge the same amount. So we're going to want to write two expressions, one for Rapid Rental and one for Capital, and we want to set those equal to each other. So our Rapid Car expression could be 55 plus 25 cents per mile. Where do I get the 55 from? Well, they get a charge of $40 and $15, $40 rental, $15 gas. That comes out to $55. And they're also charged 25 cents, but not 25 cents once, 25 cents for every mile. So there's our expression for Rapid Car. The second one is for Capital Car expression. And you can see Capital Car charges $45 for the rental fee and the gas. They already kind of added them together for us. So that's 45. And they charge 35 cents. How often? Every mile. So there's our two expressions. Now let's set them equal to each other, and we can solve. As you can see, both companies will charge the same amount if you drive 100 miles. Task number 2 will corroborate this. Might be a good idea to freeze this part for a minute or two and just take a look at the work, make sure you understand how we got that answer of 100 miles. Okay, so number 2, how much is that charge? Okay, now we know we got our two expressions now. Rapid Car was 55 plus 25 cents per mile, and Capital was 45 plus 35 cents per mile. So we set the two equal to each other, and we solve. There's our Rapid Car expression on the left, our Capital Car expression on the right. okay? And we found out on the last screen that it was 100 miles that set them equal to each other. So we evaluate, we put the 100 miles in, and you can see 55 plus 25 cents for 100 miles gives us $25, okay? 55 plus $25 gives us $80. On the other side, 35 times 100 is $35 plus 45 also gives us 80. So in either company, at 100 miles, it's going to cost you $80. $80 for 100 miles. Task number 3. If they drive 95 miles, which company should the Barry family rent from? So once again, we can use our equation, but this time, instead of putting 100 miles in for miles, we want to put 95 in and then see which is the better deal. So we evaluate both sides of the equation, and you can see that Rapid Car charges $78.75. Capital Car charges $78.25. So which is the better deal? Obviously, Capital Car will save the Barry family about 50 cents if they drive only 95 miles. So let's extend this a little bit. Provide a general rule for deciding when to pick one of these two car companies over the other. Well, we know right here that at 95 miles, Capital is better. We know that at 100 miles, they're equal to each other. So what could we say in general? Well, it seems for rentals less than 100 miles, Capital Car is the better choice. We can see that here. 95 is less than 100, and Capital is better. At 100, we know they're going to be equal. So at more than 100, Rapid Car would be the better choice for more than 100. And you can check that just by putting in a number bigger than 100 here. If we put in, let's say, 200 miles, I think you'd see that Rapid Car is cheaper than Capital Car. Why don't you guys do that? Put in 200 and see what you come up with.